Okay, let's start today. We will complete chapter 4 by today. So this will be the last section of chapter 4, which is angular momentum. Okay, angular momentum. We're still looking object as a particle. Okay, so angular momentum. Momentum, you know the definition for momentum is mv, mass multiply velocity. mv is momentum. If you tambah satu word angular in front momentum, means the momentum is turning. Right? The momentum is turning. So we'll use this diagram to represent what is angular momentum. So if you focus on the particle here with the motion, with the path here, blue line, and it was, you know that this is collinear motion, and collinear motion always move in a tangent direction. So our momentum always take the tangent velocity. So when you take m multiply velocity, you will get momentum. And you take the principle of moment. Moment means you take the force multiplied by the perpendicular distance of the object, right? So what is moment? Moment, if you have an origin and there's a force like this, and there's a distance, perpendicular distance of to the force. I draw something on the whiteboard. So moment equal to force multiplied by the d, or cross d. So this is the same principle when we look at angular momentum. So angular momentum, you take the force replaced by the momentum, right? You take the force replaced by the momentum mv, and you take the momentum multiply, or you take the cross product in matrix, and momentum cross the d. In 90 degree, you get angular momentum, which is labeled as h sub o. So this one, you use your right hand rules. So moment going this way, and you are going to turn anti-clockwise. So if you put your hand, your right hand, on the O axis, you will get your curved in finger will be the direction of your momentum. Right? Then you will get the H direction pointing up. Okay, so this is called angular momentum. Okay, so for question that later you will see, we always identify where is the direction of your velocity. You take the velocity tangent direction, or if linear, then you follow the linear direction, multiply by the mass, you get momentum. And if the question asks you to solve angular momentum, you take the line of the momentum, multiply by the perpendicular distance d from the origin O, then you get angular momentum. Okay? Or sometimes we refer as moment of momentum. Angular momentum, also another word for that is moment of momentum. You take the moment or the motion of the momentum, okay, and you derive the equation. You know that this is a vector. Vector, you have direction and scalar, or direction or magnitude. So if you want to calculate the magnitude for the angular momentum, you take the momentum multiplied by the perpendicular distance d. D multiplied by the m multiply v, which is your momentum. mv is momentum multiplied by the distance. You get moment of the momentum, or angular momentum. This is magnitude. And the direction is defined by the right hand rules. In this case, direction is going z direction. By your thumb. By your thumb. So you open your right hand, you'll get a ruler perpendicular like this, right? So what is important in angular momentum is your thumb, right? And your curve of your fingers, right? Okay, right hand rules. We use right hand rules. Unit of this angular momentum, you take it by the parameter. D is in meter. mass is in kilogram, velocity is meter per second. So you combine everything together, you get kilogram meter squared over second. Okay, so this is called angular momentum. The rest of the question later, we will identify again. We identify where is your velocity. Mass will be given. What is you need to identify is the perpendicular distance of the V line here. You need to identify what is the D. Okay, and then the direction you use the right hand rules to go to the reference point O, and then you put your right hand and you see how the momentum is turning. Okay. Okay. So vector formula is used cross. In this case, the blue pathway on the top with the particle here. So you know that this is collinear line. Collinear always take the tangent direction of velocity. So velocity multiplied by the mass, you get momentum. And if you put the particles, the blue dot here, refer to the reference position O here, you get distance. This distance R here is vector form. Similar, if you want to define angular momentum, you take the momentum multiplied by the perpendicular distance, then you get angular momentum. So HO equal to R cross MV. R cross MV will form the curvature of your fingers, right? R cross to MV, R cross to MV, and you know that your HO will be like your right hand rules pointing outside the screen. Okay. Okay, this is how you do. This is on the vector formulation. Okay. So HO is perpendicular to the plane of your MV. This one, this plane, perpendicular. Okay. So as you learn in your mathematics or calculus 1, you come across a matrix. So you know that this is vector. Vector have, and this one is in 3 dimensions. So vector in 3 dimensions, you have ijk. So what you do on the first row here, you take the identity of the axis ijk. Second row, you have the r with the distance from the reference point, with its rx, ry, rz. And then the last row is your momentum, with its mass multiplied by the velocity. If it belongs to I, means it's velocity in x direction. Z means that velocity in y direction. K means velocity in z direction. So this is a form if you need to solve with matrix, right? If you're having angular momentum, usually we use matrix solution to solve it. And how to do, you can find in the appendix B and C, in the vector appendix in the island. Okay, so this is just a recap how you rewrite the cross product in vector into a matrix form. Okay, and if it's 2D, then your K will be 0 here. Yeah. So if you're given a plane problem or 2D problem, either you're given Z and Y, then your X will be 0, or you're given X, Y, then your Z will be 0, and so on. Okay. So a moment or point O of all forces acting on particle can be related to the equation of motion. We know that every time we have a force on the particle, so this diagram here, the particle is having an external force of F. Means you combine all the force together, all the vector of force together acting on the object. We have sum of F here, and there's a distance from the origin R to the particles. So we start deriving because in chapter 4, you are not interested in acceleration, you're interested in velocity. So you link all the terms that you can find in the question into velocity. So we start with F equal to ma, which is a fundamental equation for dynamics. So we start with F equal to ma, and you know that the definition of acceleration is the time differential of velocity, dv dt. You get a. So in short form, we have a v dot. In short form, where v dot means time differential. You take velocity with time differential, you get acceleration. So moment of force about point O. So point O, if you take the moment of this force, you take R cross the F. You take R cross the F. R cross the F means the R will be perpendicular to the force. You get moment like what I draw on the whiteboard here. Okay. Then we pull the definition of force equal to ma in terms of velocity. Again, chapter 4, we are not interested in acceleration. We are interested in velocity, time, force, and mass. Okay, so we can rewrite the moment in terms of R cross mv dot. Okay, R cross mv dot, and then we continue, derive the equation. So again, if you don't know or you forget how to do the cross product, refer to Appendix B in Island. So derivative of R cross mv can be written as this one, meaning the time differential of your angular momentum. Time differential means you take your angular momentum time dt, and the right hand side also dt. So means you move your like this. So this is a vector, cross vector. You have r vector, v vector. You have a cross, although mass is constant. You pull the mass up, you still having two vector cross products. How to do cross product? I refer to Appendix B. If you forget, you'll get something like this. You'll get R dot cross MV plus R means a UV chain rules. Okay, but I won't test you in derivation. This for your info. Not so important. So if you take R dot here, this is a knot. R dot cross MV, you will equal to M multiply bracket R cross R. This one, okay, this is a cross product. You can skip these steps. It's a derivation. So you know that if you have I cross I, mean you take the x-axis I cross I, you get 0. You get 0. So this term means the front term here is 0. Okay, what is important is your momentum. This one, why is important? This is just a derivation. So what is important is the red bracket here. All your momentum that created by your momentum, or the moment that created on the O side by the force, will equal to the time differential of your angular momentum, h dot. Mean if you want to find, you want to convert the previous angular momentum back in terms of force, multiplied by the R. you do this conversion. Okay, I will show you how to do it. All right. Okay, so it means on the left hand side is the resultant moment by the forces. Left hand side is the forces, the effect of forces on the dot here. On the right hand side is the rate of changes in time of your angular momentum. Okay, so means if the question is angular momentum, this formula you write as a starting point. On the left, you focus on forces. On the right, you focus on angular momentum, MV. Yeah? So this one is just for your info. Just for your info. Okay, what is important is sum MO equal to H dot HO. Okay, H dot HO. Okay, when you use this formula is when you need to find the force acting on the object. Because momentum, as what I draw here, you need the the force multiplied by the distance F cross D, you get moment, which is on the left hand side. This one you can find from the calculation just now, angular momentum. Okay. So let's have a tutorial question on how you apply this formula. Okay. So this one you have. Okay, you look at the diagram. You know this one is chapter 4 angular momentum question already. How you know? You're given a reference point O. Other question you don't see this one. Chapter 1, 2, 3, 1, 2, 3, you don't see this one. And chapter 4, when you see there's a O in the question or reference point O with the angle and the R and the velocity, that is section 4. Means chapter 4, section, the last section, angular momentum question. Okay, so you're given a mass, travel down a smooth circular ramp. When you see the word circular is a collinear motion question. So you need to be careful finding your V tangent. And when it's a circular or there's a collinear motion, you need to recall what is your AN, what is your AT, and so on. Okay, this is a typo error, angle theta here, not U. Have the speed B. Determine angular momentum about O at this instant and the rate of increase of his speed. Rate of increase of the speed is actually his acceleration. Okay. So you draw free body diagram. You are focusing on the box. So every time that you see the question, what you want you to do, if you're given box, then you draw the box from the question. So the box, what are the first thing you do when you draw free body diagram is your weight. Start with the weight at the center, go down. Okay. And then if you don't know angle, you just copy from the diagram there. Okay. You draw the axis because it's a collinear motion. So you have weight go down and then you draw normal and tangent axis because this is a collinear motion. So draw A and T and then copy the angle. And then weight going down. You can write W equal to mg. Okay, so this will be your starting point. And then you can include the kinetic diagram inside, which is only seeing the velocity, which is going down this way, parallel to the tangent direction. And then this object do not fly off. So remember, start from chapter 3 onwards, you start to see normal force already, contact force. And so almost all the question in chapter 3 and chapter 4, you need to find the normal force first in all your solution. Meaning you take F equal to ma, and then you have x and y direction or tangent normal direction. Then you solve, you get normal force first. Once you have this one, then although this one is smooth, but you still need to find the end. Okay, because why? Because the end here will affect your formula, so on. Okay. So once you have this one, so this is just some expansion of your diagram. So this is a horizontal axis r sine theta. Okay, r sine theta, this line. So it is your hypotenuse and the in front. Okay, so we know that v always tangent in the collinear motion. Then magnitude of your angular moment. Angular moment means this one. You are given r and your v always tangent. So it create a moment of angular momentum. So you have your mv here. mv multiplied by perpendicular distance in curvature in all the circular motion. Your r always 90 degree to your tangent direction. So that's why if you look at the whiteboard here, your moment equal to force multiplied by the perpendicular distance. So your r cross the mv, you get your angular momentum, or you get your moment of angular momentum. Okay, so you get d. This is a general equation. You can rearrange this equation according to the diagram. So your d actually you can change to r. M is the same, v is the same. And here we assume anti-clockwise as positive. Why anti-clockwise? Because you use right hand rules. Your hand always anti-clockwise. Your curvature of your hand always anti-clockwise. This is positive, means it come out from the screen. Okay, so this direction always write in your answer. Anti-clockwise is positive. All right, correct. Okay. This is clockwise. Clockwise. Okay. Means the direction go in. Go in. Okay. Go in. Okay. So your thumb is pointing in. If you follow this direction. Why? Because you're following the motion of the object again. Your V is going this way. Right. So you are having like this. Pointing inside. Okay. Because you're swinging in the clockwise direction. Okay. That's why your thumb is pointing into the screen. Okay. So you want to find the angular, you want to find the rate of increase of your speed. So you from this general equation, h equal to rmv, you can convert your v into acceleration by time differential. Means you dv dt, you get a here. Okay. So what you do, you improvise this equation, highlight in the yellow color, with time differential. The whole equation you time differentiate. Okay. So you rewrite the general equation. If you time differential this yellow color h dot, you get moment at the O here, reference point here, and you're seeing forces. You're seeing forces going this way. Yeah. So this is how you solve chapter 4 question. You derive the angular momentum equation. Then you use a definition of moment at reference point O will equal to time differential of your angular momentum h dot. Okay. So here, on the left-hand side of the equation, you focus on the moment. How you know the moment? You take the mg, this one. You take mg. The perpendicular distance is r multiplied by the tangent direction. So what you do, you split the w into tangent and normal direction. You split your purple color arrow into tangent and normal direction. Yeah. So if you split your w to tangent direction, you will get w sine theta. Okay. You split into w into t direction, you get w sine theta. Okay. How to do it? Maybe you cannot see it now, but you can do it in your revision time. So you split your W into this direction and this direction. So your object is like this. So this is your theta actually. Okay, so again, if you don't know how to find the theta, you just imagine you tilt the object, you tie a rope to the center, and then you tilt it. You will see where is your angle already. Okay, you draw an object. You draw an object like this, and then you tilt according to the diagram. Then you see where is the angle already. Okay, so this is W. So you split this into T direction, WT, and also this WN here. So this one, this WT here is W sine theta. Yeah, this one. Okay, so here, actually I should write mg sine theta multiply R, but it's the same thing. It's the same thing. So moment is solved by all the force multiplied by perpendicular distance, because you don't want to disturb the R. R always constant. We don't want to disturb it. So what you can do is you split your W in the tangent direction. Why tangent direction? Because moment, definition of moment, you take force multiplied by the perpendicular distance D. So on the left hand side, you do moment on the O. Done already. Now the right hand side is the time differential of your angular momentum. So there's a dot there. So you write dt time. You need to do differentiation of what? Of your angular momentum. Angular momentum equal to R multiply mv. Okay. Of course, the more textbook answer, there's a cross here, but we do it in a scalar term, right? In a scalar term. So there's a R multiplied by the mv there, okay? So R is a constant because it's a constant length there. So R is a constant, M is the constant, mass doesn't change. So you can pull these two out. You only do dv dt. Okay, like this. And then you rearrange the equation, or you cancel out all the parameter that is same. Mass is the same, cancel. R is the same, cancel. So G sine theta equal to dv dt. dv dt equal to A. Then you get your answer already. This is the answer. Yes, because you cancel your R. You cancel your R, cancel your M, both sides. Yeah. So what is important for this tutorial question is this formula. If you focus on the force multiplied by the perpendicular distance, you get moment. Moment in chapter 4 also equal to the time differential of your angular momentum. Okay, this one. Okay, so this is the one that we important in this section. M equal to H dot. Okay, then the H definition equal to R multiplied by the momentum. Yeah, so the step of solving always the same as what you see on the screen here. First, draw free body diagram. Find the forces. Okay, why we do not consider N here? Why N, the contact force N, do not create momentum? Why? Why? Why this N? Why this red color N do not create angular momentum? What is the definition of angular momentum? Okay, because this is force, it do not come force, it do not create moment, right? The R here is not perpendicular. You get zero. Okay, you get zero. It's always along the R. So the D is zero. Yeah. Okay. Which one? This formula, you only interested in the perpendicular distance. Moment, always force multiplied by perpendicular distance, equal to the H dot. And you want to find the H here. What is your H? H is R multiplied by the angular momentum. So this is this part. The dot is dt. Okay, what is important in this formula? M equal to H dot. This is the important formula to solve the unknown in chapter 4, last section. Okay, so if you want to use the F equal to ma equation to solve, also can, which is applied to your chapter 2, F equal to ma. So also same, you'll get the same answer. F equal to mg, because in the tangent direction, you only have w sine theta. Normal is in the normal, n equal in the normal direction. So there's only one force. And because this is on the smooth circular ram, no friction force. If I remove the smooth and I give you the friction coefficient, then there is a friction force here. Okay, equal to ma, a equal to dv dt, and you have the same mass, cancel m slash the m, dv dt equal to g sine theta. You get the same answer. Okay, so this usually when it comes to chapter 4 question, you'll be forced to use this formula and this formula. Okay. Unless the question want to give you extra marks, it asks you to prove your answer with equation of Newton motion equation, F equal to ma, that your answer is correct. Okay. Okay. So this is the thing, H equal to RMB, and moment equal to H dot. Moment equal to H dot. On the left hand side is the effect of forces. On the right hand side is the effect, time differential of your angular momentum. Now we go into principle idea. Principle of angular impulse and momentum. So here you are equal the two term here. You just learn moment, and the right hand side is the H dot. H dot is time differential of your angular momentum. So how do we write in the impulse term? What is impulse? What is impulse? Force multiply time. Force, impulse, impulse, you in the previous chapter, what you do? You integrate force dt. Remember? You have this one, impulse. Principle of impulse, linear impulse and momentum. You have your momentum before plus impulse equal to momentum after. This is a previous one. Now you are on the angular impulse and momentum. So we rewrite the equation. MO equal to H dot T. We break into dV dt or dt term. So we write on the right hand side, we remove the dot into dt, 1 over dth. And we move the dt from the right to the left, then we get integration already. Yeah? So we remove the dot. We take the dot to replace as 1 over dt or dt. and we move the dt to the left-hand side, you get m dt equal to ho, or angular momentum. And every time we see dt, we do integration. And because we dt, so we integrate time. So we have m dt integrate time t1 to t2 equal to angular momentum before minus after minus before. It's the same derivation as the previous one when you learn about principle of linear momentum and impulse. Linear impulse and momentum, same, but now it's angular impulse. So the same, this is called, this stage you can call as principle of angular impulse and momentum. Angular impulse is on the left-hand side. Momentum is on the, angular momentum is on the right side. Okay, so the complete name for this principle actually is like this. Principle of angular impulse and angular momentum. A complete one, but because impulse and momentum here is in the angular term, so that's why it put in the this way. So the complete textbook for this principle is principle of angular impulse and angular momentum, but because both are angular, so we just remove one of the angular term in the name there. So you can write either the third line here or the last line, same. So we always like to put before on the left-hand side, and the mt is the angular impulse. If you write f dt is linear impulse, if the question asks you angular impulse is no longer force, it's moment. Moment of the force, that is angular impulse. If linear impulse is ft, force multiply time, get linear impulse. If you get angular impulse, you need to take the moment of the force multiply time. Then you get angular impulse. Okay, angular means something turning. Linear means it moves in the straight line, force. Always pull in the straight line or tangent direction. Okay, so this is called principle of angular impulse and momentum. Okay, the step of solving this one, like what you learned in the linear impulse and momentum, is the same. Draw free body diagram, look for the reference point, look for velocity, and then substitute value inside. Okay, we already done for this one. I just show you how to apply this one. Okay. The rest is your reading. The rest is your reading. So this we just extend what we learned previously. MO is you take force multiplied by the perpendicular distance R cross F. R cross F. And it's a vector. It's a vector. So this is just another elaboration when we come into chapter 6 later. You'll see this one later. Okay. Okay, so we know that we have two equations here of what mv plus fdt. This is linear impulse. Momentum and linear impulse. This is in the previous section in chapter 4 also. If the object moves in a straight line with one fixed constant force, then you have a linear impulse. Linear impulse, this one usually two things bend together and then either join together or move together. If you see things that swing in the circular motion, then it will become angular problems. If the object swing in the circular motion, turning, then it become angular. Okay, so you compare side by side these two. One is linear impulse, one is angular impulse. And H is angular momentum. Angular momentum. So you know that you are dealing with vector. So when you have vector, you can split into X, Y, and Z. It's the same. So I'm just showing you in the Ft formula you do in x, y, and z. You split into x, y, z component. Means you split all this v vector in x direction, y direction, z direction. Same with the force. Force is a vector, so you can change in fx, fy, and z. Same with the velocity number 2. v2 you can change in vx, vy, vz. Okay, this is linear and sorry. Oh, so it should be T1 to T2 lah. Typo error. Good, good, good observation. It should be T1 to T2. On the top is T2. Typo error on my slides. Okay. And angular momentum, we only have one. Angular momentum, we only have one because we directly deal with the vector. We deal directly with the R cross the H is R cross the momentum. M is F multiplied by the R across the R or R cross F. H2 also R and B. So these are the 4 set of questions when it comes to chapter 4 question. Okay, basically derived from these two. So it depends if you have 3D problems, then you need to use these 4 questions as 4 formula. If you have 2D problems, X and Y, then you only have 3 set question, 3 set formula, Vx and Vy, and angular momentum. Okay, every time you have a principle of something, you have conservation of something. Conservation of something, we always take away the impulse. We're not interested in impulse when you have conservation of momentum. Means momentum before equal to momentum after. Okay, then you have H1 equal to H2 or R cross MV1 equal to R cross MV2. When you have conservation of momentum, when you use this one, when the question force you to consider conservation of angular momentum, then you remove the center one. Okay, the rest is the same. The rest is the same. Okay. All right. So today what we learn principle of angular impulse and angular momentum. And then we learn one more, conservation of angular momentum, where you cancel the impulse moment. Yeah. All right. Now you look at the question, it's collinear motion. So it's sure it gives you a datum there and you're given a force. So it's very high possibility is angular momentum question. You are given 1.5 megagram. So remember to change this one into kilogram. Always a tricky part when it comes to test 2 and final exam. This one always need to change to kilogram. Force is non-constant in the F equal to something T square. So this is not constant. So you cannot use F equal to MA to solve this problem. So acceleration is not constant. So you cannot use the equation of linear motion equation. The 3 equation cannot use. So determine the speed of the car when time is so and so. So again, chapter 4, you're interested in velocity, time, mass, and force. The car initially travel with the speed of so and so. So you have initial speed given, and you need to find the speed v2. You're given v1, you need to find v2. Okay, you're given time, you're given force. So this is chapter 4 question. Okay, chapter 4, you need to find force, time, mass, and velocity. Okay. So you draw, this is a 3-dimensional question. So you have an R of 100 meter, and the car is moving this way. Yeah, it's not very curved, but just show you lah. So the weight is actually going to the Z direction. and there's a contact force N there by the wheel on the road. And the force is from the engine moving forward. So the force is always tangent to the curve. Okay, the force always tangent to the curve. Weight always pointing down. And there's a contact force N there. So your force have another force there which is in the R direction. The Fr always constant. If not, the force, the car will be off track. The F will be go outside the radius. Okay. So if you apply the principle of angular impulse and momentum about z-axis, so about here, so if you use right hand rules, you know that this is going this way, right? Going this way, right? So you know that your z is coming out from the screen. I mean your z, like this. Okay, so this one, you can ignore the angular impulse because the weight, the normal force, the weight, the normal force, and radial friction, because they act parallel to the axis or pass through it. So if you see this FR, FR is go along the R. N and W is going along the thumb. Yeah. So we only have the force that go tangent to the R. We are focusing on the R because we're dealing with the angle, the force. Again, moment is what? Force multiplied by the perpendicular distance. Here, the important distance is 100 meter. So what is 100 meter important is to the any forces that is perpendicular to it, which is the force in the circular motion. And you know that the W and the N will be balance each other. So it will eventually cancel each other because the car always stay on the road. Okay, so here we write the principle of angular impulse and momentum. H1 equal to sum of integration T1 to T2 M O dt equal to H2. So this is a principle of angular impulse and angular momentum. So H plus M dt equal to H2. We modify a little bit because initial general equation is O. Here we're focusing on the z-axis. So you change the O into Z. Your datum is the z-axis. Okay, once you change the formula, you expand the equation. You know that your H is R multiply or R cross MV. So you write R bracket MV. Integrate time 1 to time 2. You know that what is moment? Moment is force multiplied by a perpendicular distance, R cross F. H2 also same. H is R multiply R cross MV. So basically, you expand the general to the scenario in the question. And the rest is just substitution. The rest is just substitution. Any question? This one is velocity of the car after. This side is all after. This on the right hand side is all after. On the right hand side, on the left hand side is all before. I know lah, it's only one car there lah. It's just that it just represent scenario number 2. Okay. Okay, so you can put in the answer, all the substitution inside. The rest is substitution. There will be one unknown there. So R is given, mass is given, velocity is given, force is in the formula form, in the T form. So it's basically, this is an integration question. R is constant. So basically you just integrate this equation, 150 T2, you integrate, you get 150 T cubed divided by 3. R is given, MC is given, V2, you don't know. V2 you need to find. Time is given, 5 seconds. So 0 to 5. Okay, basically 0 to 5. So if you integrate this one, you get T cubed divided by T cubed divided by 3. So it's 50 T cubed. And you substitute 5 seconds there, you get a constant value. So here's one constant value, one constant value, one constant value. You only left out V2. You move the RMC to the left-hand side. You get V2. Yeah, the rest is just mathematics. Important, you know how to convert this general to the question scenario. The rest is substitution. Yeah. So the rest I just do it show it for you. It's just integration. Answer is 9.17. Your V2 is 9.17 meter per second after 5 seconds. Okay. So you, in the test or final exam, you can do in the side of your space there. You can do individually. You calculate, then you substitute back inside. Okay. So this is how you do. Any question for this one? Yeah. All right. Now the next question, you look at the question, you know you're given 3 axes, you're given velocity, you're given a spring constant there. There's a spring constant K there. So spring constant give you a force, spring force there. Okay, so a 2 kilogram disc shown at rest on a smooth horizontal surface attached to a rubber cord have a stiffness of something and initially unstretched. If the disc is given a velocity, so it means you knock it from back. So it will given a velocity of 1.5 meter per second, perpendicular to the cord. Why we know it's perpendicular? Because this, you tie something to a rope, and that object move, it move in a collinear motion. Collinear motion velocity always tangent to the curve. Determine the rate at which the cord is being stretched. The rate of which the cord is being stretched means you find that the LDT of this cord. And the speed of the disc, you need to find the speed of this means the velocity V. At the instant cord is stretched 0.2 meter. So you derive the equation using the principle of angular impulse and angular momentum. You derive that one, and then you substitute all the value there. Okay, so the first free body diagram. Okay, so you draw free body diagram in 3-dimensional. So what are the force? M go down, right? M go down, right? Go down to the parallel to the Z, right? And then the N also pointing up, right? So just now you learned in the car scenario, W and N do not create impulse. So you can ignore that one. But in the free body diagram, you need to draw, because free body diagram is about forces. Okay, so there's a path. You draw the path with its collinear motion, and then the velocity is tangent, right? V. So it move lah. It move in the 3 position. You just simulate lah. Okay, so you have V1 with its 1.5, and you need to find the V2 when it was stretched 0.2 meter. So originally you are having 0.5. Original length is 0.5. What you need to do is you need to find when it's stretched 0.2. So when stretched 0.2 means the length become 0.7. So the x here is 0.7. Okay, so you split your V. What you do, you just observe, you split your V, because I'm going to share this slide with you later. So observe the slides. So you split your force into radius direction or tangent direction and normal direction. Okay, so you have tangent direction. You have this direction and this direction. So you are stretched with 0.2, right? This original length and stretch 0.2. W and N is there. FC is going in. Yeah. What time class Dr. Dali start? 3, yeah. So it's time already. So I go very fast. You use conservation of angular momentum. Okay, you use angular conservation of momentum. You use the definition. RMV equal to RMV, 1 equal to 2. You put in all the value, you're able to find the velocity. Yeah, so V comma D2 is 1 point something. And you need to use, because spring, you have energy. Because 1 is missing here, V double comma, you need to use conservation of energy, kinetic plus potential. Spring, something that can, in a spring effect, you have a spring potential. So half mv squared kinetic plus half kx squared, before equal to after. You put in all the value there. X is the extension of the spring. Before is 0, after is 0.2, you scratch 0.2. Put in all the value. D2 is missing in the equation. So D2 equal to 1.360. So D2 you determine through Pythagoras theorem. You have this component, you have this component, you're able to find this one. You have D2, you have D comma D2. To find V double D2, you use Pythagoras theorem. Means Pythagoras, this is this is your side, Pythagoras theorem. A, B, C. So C square equal to A square plus B square. This is 90-degree perpendicular. So the answer for D2 double comma is 0.8. But don't worry, if this kind of question come up, the question will guide you. It will ask you use conservation of energy and principle of something to solve. Okay, the rest steady float, this one cover in your float dynamic one. So this one just for info, go home and read. This one also, go home and read. It's not inside your scope for dynamics. Tomorrow we start chapter 5. Spring. Cook.